Alright, in this section here we're going to be finding the distance between 2 points in the Cartesian plane. And we're going to be doing that by using the distance formula, of course. And so I'm going to attempt to draw the XY plane here. Alright, let's pick 2 points here. I'm going to pick a point here at the origin, make it real simple, and then a point up here, and we'll say this is at 2, 2. And this point here is at the origin 0, 0. And we want to find the distance between these 2 points. And so let's just draw a line here. So we want to find the distance of this line here. Okay? And the way we're going to look at this is, first off, we're going to look at it using the Pythagorean Theorem. Alright, which you should be familiar with, where this is the distance right here, x, and then this would be the distance y right here. Well, we know that this is a 2 right here. Okay, so we go over 2 units and then up 2 units. That gives us this address right here. Alright, so we're going to use r squared is equal to x squared plus y squared. And so this right here would be considered r, which is going to be the distance, right? This is the hypotenuse of this right triangle right here. Well, we know what x is. X is the distance between the origin and 2 on the x-axis. We'll call that the x-axis, and that the y-axis. Okay? Alright, so this would be 2 squared plus, and then y is this distance here, and we're going up 2 units, so I'll put a 2 right here. So this is 2 units this way, and then 2 units right in here, the distance. Okay, and so we end up with y is 2 squared. So this side of the triangle is 2, and this side of the triangle here is a distance of 2. And to find r, we just use this formula here. So we have 2 squared is 4, and 4, which is 8. But we need to solve for r in this problem, and so we just square root both sides. And of course, when you square root a square, right, that square just disappears. Now we can break this up as to 4 times 2, which is 8. But you know the square root of 4 is 2. So we end up getting that side of the triangle is 2 times the square root of 2. So this distance here is going to be 2 square roots of 2, right, the distance. Well, we just found the distance between 2 points. Now let's work another example. So we'll clear that out. And this time, that's really getting annoying. Okay. So, actually, let's do a quiz here. I'm going to let you figure out, we'll say this is 2 here, what the distance is between the origin and this point right here. Okay, so we want to find this distance. So this is going to be a quiz. Okay, so pause the video and try to find the distance between the origin and this point right here, which I guess I should say is this ordered pair. This is its address, 1, 2, and 0, 0. So there's your 2 points. You try to find the distance. Pause the video, come back, and I will work it out for you if you can't figure it out. Okay, so we're given these 2 points, and now we want to find the distance. Well, we know that this distance here is 1, and this distance is 2. So let me just drop another triangle over here. So this side is not x, but this side is 1, and this side is 2, and we're going to use the Pythagorean Equation, really is what it's called, to find the distance or the hypotenuse of this right triangle right here. Alright, so this is 1 squared plus 2 squared, and then of course we square root both sides to get r, and this would be 1 squared is 1 and 2 squared is 4, and that would be the square root of 5. The square root of 5. So this distance here between here and here is the square root of 5. Okay? Alright. Okay, now what we're going to talk about is we've been drawing our triangles here where they're starting here. We have a point at the origin, but now we're going to move this triangle around and still try to find the distance between 2 points. Alright. So we carefully draw the Cartesian coordinates plane there, rectangular coordinate system, whatever you want to call it. It's the Cartesian plane. Alright, this time here we're going to shift the triangle this way, and we're going to let this be 1 and 3, and then we're going to go up 3 units. Try to keep this to scale here. And we want to find the distance between this point and this point here. Okay? So we're going to try to find the distance between this point and this point. Now, let me go ahead and write these 2 points up here. So this point is 1, 0. And this point here, we're over 3, and we're up 3. Okay, so here's our 2 points. Now, if we looked at this as a right triangle, so this distance, this side is going to be what? 2. Okay, that would be the distance of this side, and then this side here is going to have a distance of 3. Right? So if we were to use our formula, r squared is equal to, so this would be 2 squared plus 3 squared, this side here, to get r. Right. Then of course we want to square root it. Alright, solve for r here, so this is 4 plus 9, and that ends up being the square root of 13, right? Okay. If I were to say, if I called this point right here x1, y1, and we called this point right here x of 2, y So we've identified our 2 points in a general sense, where we're just giving them x of 1, y of 1, and then this point x of 2, y of 2. Well, we're getting somewhere with all this eventually. So x of 1, if I were to find the difference between, if I wanted to find this number right here, okay, let me just write out these 2 points again. This is x of 1, y of 1, and x of 2, y of 2. And I want to find this number right here, the difference between 3 and 1. Well, if I go ahead and label my numbers here, so this point was 1, 0, 1, 0, and this point here was 3, 3. Okay, so x of 1 is 1, y of 1 is 0, x of 2 is 3, and y of 2 is 3 here. If I wanted to look at the difference between x of 2 and x of 1, right, so this was 3 minus 1 is 2, and that's our 2 right here. Okay. Now, there's some notation. This little triangle here is a delta, the Greek letter delta, delta x. And what I'm going to call delta x is, it's going to be for short for x of 2 minus x of 1. You see that? X of 2 minus x of 1. X of 2 minus x of 1 is our delta x. This is our difference. Alright, and our x's. So delta x in this particular case would be equal to 2. Alright. But if we were to look at y, what about delta y? Well, delta y is y2 minus y1. But in this particular case, y2 is 3, and y1 is 0. So delta y is going to be 3. Right? Delta y is 3, and that's the change in y is what that means, the difference in our two y values. So delta y is 3 here. Alright. So what we're going to want to do, alright, so we're finding, we're now using this formula, delta x squared plus delta y squared. In other words, the change in x squareds plus the change in y squareds. And of course, we'd need to square root this. So let's just do that. Plus delta y squared is r. Okay? Alright, so now let's look at another example. So we're slowly developing our distance formula. So let's go ahead and clear everything out and look at another one. So this time we're going to shift that triangle, instead of horizontally, we're going to shift the triangle up. So we're going to have a point here, and at 0, 1, and then we're going to have another point up here, and we'll call this 1, 3. Alright, so we got 2 points, and we want to find the distance between these 2 points right here. So this is the distance that we're after, right here. Okay, that's the distance that we're looking for. So you try to find this distance and get back to me. Pause the video, you try to find it, and then I'm going to explain it. Whoops, didn't mean to put that line there, but this is 1 right here. All right. Okay, so we called this distance here delta x, and this distance was known as delta y. So let's take a look at that. So delta x, remember we said was x of 2 minus x of 1. Okay, so this was our difference in our x coordinates, our first coordinates. So let's see exactly what that is. We have 1 minus 0. So 1 minus 0 is just 1. Well, yeah, it's just a distance over 1 unit, as I can see here. But now let's look at delta y. Delta y, remember, was y2 minus y1, and that would be 3 minus 1, which is 2. So this side right here of the triangle is a distance of 2, and this is a distance of 1. So remember, r squared is equal to delta x squared plus delta y squared. And remember what delta x squared was. It was x of 2 minus x of 1 squared. And delta y is y2 minus y1 squared. And of course, we have to square root all of this, okay, which is r. So we said that x2 minus x of 1 was just 1 squared plus, and then y2 minus y1, we said that that was 2 squared, and of course we got to square root the whole thing, and r represented the hypotenuse of our triangle. And so now we're left with 4, 5. So the square root, woo, I already did square root. Okay, let's redo this. Well, I'll just write it here. The square root of 5. Okay, square root of 5. And that would be this part of the triangle, or the distance between this point and this point here. So what needs to be said now is, this is our formula that we use, except we're going to replace r with the letter d, where d stands for the distance. So we have now slowly developed our distance formula. Given 2 points in the plane, we can now find the distance between these 2 points. And that is our distance formula. Okay, so we're given 2 points. So let's say that we have a point here and a point up here, okay? And we want to find the distance between this point and this point here. Now remember, our coordinates are x of 1, y of 1, and we called this point x of 2, y of 2. And we want to find the distance. So let's just do this generally. So remember that the distance is equal to the square root of, okay, this is our delta x, our change in x, which is x of 2, minus x of 1, and we square it, plus y2 minus y1. Now if I were to give you this in the very beginning, okay, you might not know what in the heck, how I even came up with this, right? So that's the reason. Well, now that you've seen how this distance formula works, we're going to work a problem here without really explaining the distance formula. So I'm going to give you 2 points, and we'll give you the point 1, 3, and the point 5, 3. And you want to use this formula up here to find D. Okay, so why don't you pause the video and try to work that out and come back, and then I'll see if we can come up with an answer on that. Okay, so this is how it works. We got D is equal to the square root. And of course, you see I'm not drawing any pictures now. We have now grown up. We don't need pictures. So x of 2 minus x of 1. So this would be 5 minus 1 squared plus 3. What do we got here? 3 minus 3. 1, 3, 5, 3. Okay. Just go with it. And of course, this ends up being 5 minus 1 is 4, and 4 squared is going to be 16. And then that's just 0. So I didn't need all that part of the square root, but square root of 16 is 4. So the distance is 4. Let's look at a picture here. Let's actually plot these points and find out where this is at. So we go over 1 and up 3. So we'll say that this is 1 and 3, and it doesn't look to scale, but that's okay. And then we're going to go over 5. We'll say that's 5 and up 3. So the distance is 4. Notice there wasn't any change in y. This is just a horizontal line. Alright, one more and we'll be done. Okay, so you're going to be given the points -2, -1, and the point 3, 1. And you find the distance between these 2 points in the plane. Pause it, come back, and I'll show you how to work this out. Alright, so distance, first thing we're going to do is we're going to write up the distance formula. And so this is, remember, x of 2 minus x of 1 squared plus y2 minus y1 squared. Okay, so this is going to be our x of 1, y sub 1, x of 2, and y sub 2. Okay, so we're going to have 3 minus 1, or 3 minus 2, and that is squared, plus 1 minus a minus 1. Now you notice I'm putting parentheses around this minus here. And then of course we got the square root. I get in a hurry and things get sloppy. Alright, so this is 3 minus a minus 2, so this becomes 3 plus 2, and 3 plus 2 is 5, and 5 squared is 25. Alright. Plus, so this is 1 minus a minus 1, so this becomes 1 plus 1, which is 2, and 2 squared is 4. And this is the square root of 29, which cannot be broken down any further. Okay. Now I'm going to mention one more thing before I go. You could put x of 1 here and x of 2 here. As long as you put y of 1 here and y of 2 here. It doesn't matter, you're still going to get the same distance. Alright, you're still going to get the same distance. Let me repeat that. X of 1 can go here, x of 2 can go here, y of 1 can go here, and y of 2 can go here. But it must be in that order. Thank you.